What's the behavior of this series? 5 divided by 2n squared plus 4n plus 3. You might say, hey, I want to apply the integral test. To apply integral test, you have to check 3 conditions. The function is continuous, positive, and decreasing. And at the same time, you need to check the integral of 5 dx divided by 2x squared plus 4x plus 3. I'm going to give you an easier method. Comparison test. In the method of comparison test, if you can show that an is less than equals to bn, and if the larger series bn converges, then you can conclude that the smaller series converges as well. Okay, let us take a look at this rational expression. Check this rational expression. It is 5 divided by 2n squared plus 4n plus 3. Can I find something on the right-hand side, a fraction that has something on the numerator, something simple on the denominator, and I already know how to deal with that series? Can we find a simple rational expression or rational function on the right that we already know the behavior of its series? This is all you need to do. You need to find something on the right-hand side that you already know the behavior of its series. Take a look at your denominator. For the denominator, 2n squared plus 4n plus 3 is always more than equals to 2n squared. There is no doubt there. This is basic algebra. Using algebra, we are not using anything else. 2n squared plus 4n plus 3 is always more than 2n squared. So if I flip this, it's basically saying that, hey, if a is more than equals to b, 1 over a is less than equals to 1 over b. So here you have 1 divided by 2n squared plus 4n plus 3 less than equals to 1 divided by 2n squared. Very well. So far, I found my denominator. My denominator is 2n squared. Let me use a different color. What is on the numerator? Just use 5. No one's stopping you. You can multiply both of these fractions by 5 and then you're done. If you multiply this one by 5, multiply this guy by 5, then 5 divided by 2n squared plus 4n plus 3 is less than equals to 5 divided by 2n squared. So we have a simpler fraction to deal with. Instead of working with this 5 divided by 2n squared plus 4n plus 3, I'm working with this simpler fraction 5 divided by 2n squared. Now I need to check to see if this guy is a convergent series or not? Well, it's super easy for me to see the series, the behavior of the series. This is just a P series, and n is more than 1. So take a look. Let me just erase this algebra. Use the same color. The summation of 5 divided by 2n squared, n starts from 1, goes to infinity, can be written as 5 divided by 2 times the summation of 1 divided by n squared, n starts from 1, goes to infinity, which is a P series. The summation of 1 divided by n to power p, n starts from 1, goes to infinity, and since p is equal to 2 and it is more than 1, we have a convergent series. So what's the meaning of that? Since the larger series is convergent, the smaller series is convergent as well. So we conclude that the summation of 5 divided by 2n squared plus 4n plus 3, n starts from 1 to infinity, also converges. As easy as that. So let us recap what we did. I'm going to check to see if this series is a convergent series or not. The very first thing that we learned in this class is integral test. To check integral test, you need to check if it's positive, continuous, decreasing, then start taking the integral. But I'm going to use a simpler method, which is comparison test. Comparison test says, hey, if an is less than equals to bn, and if the larger series is convergent, you can conclude that the smaller series also convergent as well. Since it's a simple algebra, we can find a simpler function, fraction on the right-hand side, which is 5 divided by 2n squared. Why is that? Because 2n squared plus 4n plus 3 on the denominator is more than equals to 2n squared. And if I flip this, I get 1 divided by 2n squared plus 4n plus 3, which is less than equals to 1 over 2n squared. If I multiply by 5, I get the exact same series on the left-hand side, and I just need to analyze the right-hand side series. Since the right-hand side series is nothing but a P series, P is equal to 2, more than 1, so we have a convergent series. Since the larger series is a convergent series, so the smaller series also a convergent series as well.